Welcome back. Today I'm going to talk about another RHACM capability, namely application lifecycle. I'm going to deploy an ARM-based application as well as an Intel-based application from RHACM onto my home hybrid cluster. Now it's time to actually create an application and run it on the hybrid cluster. But before we can do that, I need to clone my projects onto the RHACM hub. This is the ARM project. Oh, wrong terminal. Now I can do it here. Let's see. Okay, change to that directory. Apps, HTTP. First of all, I'm going to create a namespace for the application. The namespace is called HTTP. And then I'm going to deploy the application. Note that the application is incomplete. I could have put the placement rule in the application itself, but I want to show you what's in the placement rule. So let's get back to the RHACM console. Go to Manage Applications. You can see I just created this particular HTTP app. Let's go to Resources. As I said earlier, this is not going to work because I haven't actually created the placement rules. So I could have put the placement rule in the application YAML itself, but I just want to show you what it looks like. So I just click on that Create Placement Rule. Okay, I just replace this with my placement rules. So it should be looked at that in here I have the cluster selector to match the labels. For environment equal depth, the cluster is hybrid and the ingress is traffic because there are different ways of doing ingress. And I don't want this to be deployed onto Openshift cluster because Openshift cluster does not use ingress and it does not have an ARM processor. That's why when I actually imported the cluster, I created these additional labels called cluster and assigned hybrid to it and then ingress traffic to it. So once I created those labels, I can actually use them in the selection of where to run the application. So remember, I only have one hybrid cluster in here, so it seems that it's going through lots of hurdles in order just to deploy an application. But imagine when you have many hybrid clusters, that you don't have to go into each one of them and then deploy the application. Like because doing it so many times, you're bound to make some mistakes. So what I'm going to do is save it. Let me see if the application has been deployed. Let's get back to this thing here. So it's up and running. So let me just invoke that. So that's the application. This is the application I created when I was playing around with Docker Swarm. And this is to test out the load balancer. So you can see that the Docker name, port name is displayed here, and it put together with its IP address. So if I do this sufficient time, you can see there is a change. So there are actually 2 ports running. So this means that I've actually deployed this application onto my hybrid cluster. Let's go back here, overview. Now let me go to the Openshift managed cluster. You can see there's no namespace called HTTP in here. Contrast to this one. This HTTP. So that means that particular application was not deployed onto the Openshift cluster, because as I mentioned earlier, I actually use the extra labels to select where to deploy the application. I only choose the cluster that has ARM processor to deploy this application, and it selected this one because it is the only one that has ARM processor. So far, I have not described to you what's in the application.yaml. In order to understand the application .yaml, you need to learn about a number of CRDs, including obviously application, channel, subscription, placement rules, placement binding, etc. So it probably take too long to describe everything in here. So what I'll do is I'll just put some description in my GitHub page to get this RHACM ARM app. And here is tree directory of that particular Git repository. So you get app, HTTP, application.yaml, etc., right? And also in the application.yaml, it points to the resources HTTP directory to get all this deployment information. So when using traffic, it does not create a route. It actually creates using traffic to expose the application using notepad. So you'll find all that definition in here. Remember, like early on in the demo, I show you that I was using a taint to actually prevent Intel images to be deployed onto the ARM node. So in order to deploy an application onto an ARM node, you need to have a specific toleration for it. So let's have a look at this HTTP deployment YAML. If you look at it here, so in the deployment, I'm actually specifying a toleration, which is exactly the same as how I defined in the taint. So the key is kubernetes.io/arch, and when it's equal to ARM64, and the effect is a load schedule, if it matches that taint, then it can be deployed on that particular node. And also in here, I also added a node selector. So I specifically asked it to deploy it onto an ARMed node. And that is how I can deploy an application on an ARM node. And I said earlier, as you have seen when I'm giving a demo on the deployed application, I'm actually exposing that application using notepad. So it is quite different from using Openshift, which creates a route. Next, let us have a look at how to deploy an application onto the hybrid cluster, onto the Intel nodes. Let me just clone that application here. Again, let us first of all create the namespace. And then I'm going to create the application itself. Again, it's not going to run because it's again missing the placement rule. So let me just go to the RHACM console, refresh it. Then I'll see this Ethernet pad, Etherpad. Go to resources. I'm going to create a placement rule. Let me paste the content of the placement rule in here. Again, you can see that I'm specifying these match labels to match the hybrid cluster and traffic. So in principle, I don't even need to match the cluster equal hybrid. As long as it uses traffic as ingress, it will work. Note that this particular application, the configuration will not work on Openshift because Openshift does not use the traffic ingress. It uses routes or routes. So it's simple to be there. Let me have a look at how it's progressing. Oh, wrong terminal. So you can see the Etherpad. You can see the Etherpad. The Postgres database is already running. So let me have a look again. Now it looks like everything is running now. So let's have a look at how Etherpad runs. Just want to create pad, call my pad. Close it. Let's retrieve it. Now, getting that back. And this is a much more complex deployment in the sense that it requires a relational database. In the previous deployment, it only involved one image to run in the container platform. So this is how you deploy applications using RHACM. Now let's have a look at the RHACM UI to see what else can we find out about this particular application. Let's click on the overview. But before we do that, we can have a look at here. It has one subscription. It is deployed into one managed cluster. It has a one channel, one placement rule, and all this information. Now, if I click on overview, you can see this particular application consists of a subscription, was deployed in a cluster, and have a secret called either. The service is called, have a service for the Postgres database, and have the ingress for the Etherpad, and so on and so forth. You can find out about all that information in this particular diagram. Let's have a look at the previous application, the HTTP app. You can see that this is much simpler than the other one, right? So it only have a cluster deployed on the cluster. The deployment is called HTTP. It has a replica set, and the ingress is called HTTP ingress, etc. You can see that it's a much simpler application than the previous one. In the demo, I use a Git repository to house all my application resources, but that is not the only option. You can also use ham repositories or object storage repositories. In the next video, I'm going to show you another capability of RHACM, namely governance, risk, and compliance. So stay tuned.